Today's daily code problem of the day is the longest subarray with maximum bitwise and number 2419. For this problem, we're given an integer array called nums of size n, and we need to consider a non-empty subarray from nums that has the maximum possible bitwise and. So this is kind of like a trick problem. If we take into consideration how the bitwise and operation works, I'll use example 1 here. So we have 1, 2, 3, 3, 2, 2. We represent these each as their bitwise representations. 1 would be 0, 1, 2 would be 1, 0, 3 would be 1, 1, and then 2 again would be 1, 0. A bitwise AND operation requires for us to take the bit representation of one number, so 3, for example, is 1, 1, and the bit representation for another number, so 2 is 1, 0, and we're going to compare it like a true or false. So 1's being trues, 0's being falses. And now if we have true and true, it's going to be true. However, if we have true and false, it's going to be false. So if we're looking at the bitwise representations of a number, 1 being true, 0 being false, 1 and 0 is going to be 0, 1 and 1 is going to be 1. Now, let's say, for example, we had the number 4. So we have 1, 0, 0. No matter what we do, these zeros are going to take over, right? So the maximum number we could possibly get, and we would have zeros here. So ultimately, this would end up being like nothing. The maximum number we could get is whatever the maximum number is in the array. So using this information, we now have identified that it's kind of like a trick problem. The maximum bitwise AND operation is the maximum number in the array. So we're going to have to identify the maximum number in the array and then find the longest subarray with that maximum number. Now, for a subarray to be valid, the numbers cannot be manipulated. Like we can't take 2 and put it over here, or we can't, let's say if we had a 3 here, we can't ignore these 2's and say our longest subarray is these 3. That's not how it works. So we need to identify our longest subarray, which is numbers in a row of our max occurrence, which is pretty simple. So we're going to do this in Rust, and because we're in Rust, we're going to need 3 variables: the longest, which is going to keep track of our longest subarray; the current, which is going to keep track of our current subarray; and max, which is our current max identified number. All 3 of these need to change, so they'll be immutable. So let mut longest equals 0, let mut current equals 0, and let mutable max equals 0. Now we have our 3 variables. We're going to loop through the array once. We'll do 1 pass, and we will track the longest subarray as we go through. So for each index in from 0 to nums.length, we are going to check first if our nums of I value that we're currently looking at is greater than our previously established max. If that's the case, we need to reset all of our values, right? So max is now going to equal whatever our newly identified maximum value is. And then we're going to have to update our current value to be equal to 1, since we have 1 occurrence of that now. We're looking at it. And then we're going to need to update longest as well, and we can set that equal to 1, simply because the longest subarray is always going to be length 1. But in this case scenario, like we just found a new maximum number. Whatever the previous longest subarray we have identified is no longer valid because that's not the maximum bitwise AND. So that's our first case. Our second case we're going to check is else if our nums of I value is not equal to the current max number, then it's kind of like we need to break out of what we were doing. So for example, we see 3, okay, new max number. Let's update our current, update our longest, update our max. Okay, we see it again, we'll add it to our current, and then boom, all of a sudden we see a new number 2. That is not equal to our max. We need to update the longest, see if it can update, if we have a new longest, update our current, and then we will continue. So if nums of I is not equal to max, we'll say, okay, does longest need an update? We'll check that by doing longest.max check it against current, and then we will update current to be equal to 0, since we're now looking at a number that is not our max value. And then our final case is simply updating current, because if it's not a new number greater than our max, and it's not equal to our max, then it has to be equal to our max, and we'll increment from there. Finally, we could simply return our longest, and then we'll check once again dot max against our current, and that's it. So if we run this, passes our test cases, and if we submit it, passes all solutions. So thank you, and follow for more daily LeetCode solutions.